SDG labs! Ah! I would say, what is the y-intercept? It's -1. What is the x-intercept? I'm sorry, I told you what is a y-intercept, and I gave you a number, but technically I should give you two numbers. It's 0, -1. That's the coordinates of the y-intercept. If I'm asking you, what is the y-intercept, I'm asking you for a point. If it's a point on a Cartesian coordinate system, that's what this is, the x and the y-axis, then it has to have two numbers associated with it. That's it. Alright, the x-intercept is, well, something comma 0, and I would say that number is maybe 0.5. It looks to me like it's in between. I'll be honest with you, I can't really tell because I didn't draw the graph nicely. And even if you look at this thing right here, you can't really see it perfectly. So I would be rather, see the thing about making a graph is it's nice to look at something and identify it immediately. You look at it and you're like, well, it's between 0 and 1, I would say about half. It could be 0.6, but I don't know, I can't really tell from the graph, but I can tell you what the ballpark is. See, now what's nice about doing it mathematically, so that's doing it graphically, what's nice about doing it mathematically is you will get the exact answer. That's better to me than giving a ballpark, especially if you're doing something with important calculations associated with it. Alright, so what do? How do we find the x-intercept? Well, we set y equal to 0, so we have 0 is equal to 2x minus 1. I'm going to solve for x, so I'm going to add 1 to both sides. I have positive 1 equals 2x. I'm going to divide both sides by 2, and I've got x is equal to 1 over 2. Hey, that's what I wanted. It was 0.5. That's what I guessed it. That's what it ended up being. I proved it. My x-intercept is 1/2, 0, or like I wrote up on the board, 0.5, 0. The y-intercept, what you do is you set x equal to 0. Well, that's really nice because setting x equal to 0 puts that equal to 0 and you get -1. So y equals -1. Your coordinates is 0, -1. That's solving it. I did it graphically, and I did it algebraically, mathematically, and I got the same answer. I'll be honest with you, sometimes when you graph it, you'll be able to get an answer and then you'll get a little bit of a different answer for your mathematical solution. And that's fine because the graphing isn't as super accurate as the math is. The math is the most accurate you can get. The graphing is just a ballpark where your eye thinks it is. I like doing both. I can't necessarily say, I think I said earlier that I like the math way better. I can't necessarily say that's completely true because to be honest with you, in my head, I do both. When I solve a math problem, I do both. I do it the hard way, and I do it the easy way. Because if the easy way gives me kind of a good idea of where it should be, and if the hard way lines up with what the easy way says, then I know I did it correct. But I'll be honest with you, if I ended up like solving this out and I end up getting like instead of 1/2, maybe I did something dumb with my math and I end up getting x equals 3 or something like that. Then I'll be like, wait a second. Oh, I should have, or like let's say x equals 2. Oh, I should have divided that 2 instead of, and then I'll say, wait a second, that's a mistake. That's a problem because it doesn't match anywhere up with the graph that I have. So I must have accidentally multiplied both sides by 2 when I should have divided both sides by 2. Shoots, bro, up out.